To calculate the total demand load in amps for a farm with 3 buildings without a dwelling, each having single-phase 120/240 volt service, follow these steps. Firstly, convert kilowatts to amps for each building. For single-phase systems, kilowatts are used directly since voltage is constant at 120 volts in this example. Secondly, calculate the amperage for each building. The formula is amperage equals kilowatts divided by volts. For building 1, with 18 kilowatts, the calculation is 18 kilowatts divided by 120 volts, which equals 150 amps. For building 2, with 14 kilowatts, the calculation is 14 kilowatts divided by 120 volts, which equals 117 amps. For building 3, with 12 kilowatts, the calculation is 12 kilowatts divided by 120 volts, which equals 100 amps. Thirdly, calculate the total demand load. This is the sum of the amperage for each building. The total demand load is 150 amps plus 117 amps plus 100 amps, which equals 367 amps. Therefore, the total demand load is 367 amps. The solution emphasizes direct calculation based on individual building loads and their respective amperages, using the formula amperage equals kilowatts divided by volts, then summing the individual amperages to obtain the total demand load. In electrical calculations, understanding how loads are distributed and the direct application of Ohm's law or power formulas is critical. You might encounter scenarios where diversity factors or demand factors are applied. These factors account for the fact that not all loads will be operating at their maximum simultaneously. Demand factors are typically percentages and are applied to the total connected load to estimate the maximum demand. Diversity factors are the ratio of the sum of individual maximum demands to the maximum demand of the entire system. These factors are particularly useful in large installations or when dealing with multiple loads with varying usage patterns. Also consider voltage drop. Voltage drop occurs when the voltage at the end of a conductor is less than the voltage at the source. This can be due to the resistance of the wire and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code, or NEC, provides guidelines for calculating voltage drop and specifies the maximum allowable voltage drop for different types of circuits. In the context of farm buildings, understanding the specific types of equipment and their operational characteristics is crucial for accurate load calculations. For example, motors often have high inrush currents during startup, which can impact the overall demand. It's essential to refer to the equipment's nameplate for accurate voltage, amperage, and power ratings. The NEC provides tables such as Table 310.15b16, which specifies the allowable ampacities of insulated conductors rated up to and including 2000 volts. This table helps determine the appropriate conductor size based on the calculated load and ambient temperature. When dealing with multiple buildings on a farm, it's important to consider the distances between the buildings and the main service panel. Longer distances increase the potential for voltage drop, which may necessitate the use of larger conductors or higher voltage distribution systems. The NEC also provides guidelines for grounding and bonding, which are essential for safety. Proper grounding and bonding help to minimize the risk of electrical shock and ensure that overcurrent protection devices operate correctly. It's also essential to be aware of any local electrical codes or regulations that may apply to farm buildings. These codes may have specific requirements for wiring methods, grounding, and overcurrent protection. The NEC is a comprehensive document that provides guidance on a wide range of electrical topics. It's essential to consult the NEC and other relevant standards when designing and installing electrical systems in farm buildings. Consider the specific equipment used in each building, such as lighting, heating, cooling, and machinery. Each type of equipment has different power requirements and operational characteristics. Lighting loads can be estimated based on the type and number of fixtures. Heating and cooling loads can be calculated based on the size of the building and the climate. Machinery loads can be determined from the equipment's nameplate. When calculating the total demand load, it's important to consider the diversity factor. The diversity factor accounts for the fact that not all equipment will be operating at the same time. The diversity factor can be estimated based on the type of equipment and its usage patterns. For example, lighting loads may have a diversity factor of 1.0, while machinery loads may have a diversity factor of less than 1.0. The NEC provides guidelines for calculating diversity factors for different types of loads. In addition to the NEC, other relevant standards may apply to farm buildings. For example, the National Fire Protection Association or NFPA publishes standards on fire safety, which may include requirements for electrical systems. The American Society of Agricultural and Biological Engineers, or ASAB, publishes standards on agricultural engineering, which may include guidelines for electrical systems in farm buildings. It's essential to consult these standards and other relevant resources when designing and installing electrical systems in farm buildings. Also ensure that all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous, and it's important to follow all safety precautions to minimize the risk of electrical shock and fire. Remember to always de-energize circuits before working on them and use appropriate personal protective equipment. Furthermore, regular inspections and maintenance of electrical systems are essential for ensuring safety and reliability. Inspect wiring, connections, and equipment for signs of damage or wear. Replace any damaged or worn components promptly. Test ground fault circuit interrupters or GFCIs regularly to ensure that they are functioning properly. The NEC requires GFCIs in certain locations such as bathrooms, kitchens, and outdoor areas. Proper planning, design, installation, and maintenance of electrical systems are essential for ensuring the safe and reliable operation of farm buildings. It's important to consult with qualified professionals and follow all applicable codes and standards. By following these guidelines, you can minimize the risk of electrical hazards and ensure that your farm buildings have a safe and reliable electrical system. Consider future expansion and increasing the size of the service entrance. It is cheaper to do it now rather than later, and you will not be stuck with whatever is there. When designing an electrical system for farm buildings, it's important to consider future expansion. Farm operations often grow over time, and electrical needs may increase. It's therefore prudent to design the electrical system with sufficient capacity to accommodate future growth. This may involve installing a larger service entrance, using larger conductors, and providing additional circuit breakers. By planning for future expansion, you can avoid costly upgrades later on. Also make sure to use appropriate wiring methods. The NEC specifies different wiring methods for different applications. For example, underground wiring may be required in certain locations, while surface wiring may be permitted in others. It's important to select the appropriate wiring method based on the specific application and the environmental conditions. The NEC also provides guidelines for the installation of wiring, including requirements for support, protection, and separation from other systems. The location of electrical equipment must be in a suitable place, away from livestock. Electrical equipment should be located in a safe and accessible location. It should be protected from damage, moisture, and other environmental factors. The NEC provides guidelines for the location of electrical equipment, including requirements for clearances, ventilation, and protection from physical damage, and install proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. It's important to install overcurrent protection devices that are properly sized for the circuits they protect. The NEC provides guidelines for selecting overcurrent protection devices, including requirements for ampacity, interrupting rating, and coordination. You will need surge protection as well. Surge protection devices are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, switching transients, and other events. Surge protection devices can help to prevent damage to sensitive electronic equipment. The NEC provides guidelines for the installation of surge protection devices, including requirements for grounding and bonding. Energy efficiency should be considered. Energy efficiency is an important consideration when designing electrical systems for farm buildings. Energy-efficient lighting, heating, and cooling equipment can help to reduce energy consumption and lower operating costs. The NEC provides guidelines for energy efficiency, including requirements for lighting controls, insulation, and motor efficiency. The more you conserve, the more you save. If you are not sure, contact a professional. Designing and installing electrical systems for farm buildings can be complex and challenging. It's important to consult with qualified professionals such as electrical engineers and licensed electricians to ensure that the electrical system is safe, reliable, and efficient. Professionals can help you to select the appropriate equipment, wiring methods, and overcurrent protection devices. They can also help you to comply with all applicable codes and standards.